There's our objectives for the day. I know the difference between rational, irrational, and non-real numbers. Then I can change a decimal into a fraction. But we should also be able to change a fraction into a decimal, which I believe we've done already. And then no, we haven't done that, no. But we have changed mixed numbers into fractions and improper fractions to mixed numbers. Okay. Then I can order decimals from least to greatest, and then I can evaluate square roots. That's that last one. That's the one that we're going to need the calculator on some of it. But the other parts that we will not be using a calculator for, we won't use a calculator because it'll be on the quiz. Okay, so the difference between rational and irrational numbers, and some of the questions on the assignment, that's just what it's going to be. Is this number rational or is it irrational? That's what we want to know. I believe we may see some stuff that differs between real and non-real, but we'll get to that. But not yet. So rational number is any number that can be written as a fraction, no matter if it's proper or improper. But it's also a decimal that terminates or repeats. Okay, so a common repeating decimal, let's start there. A common repeating decimal would be something like 0.3333. Now, it goes forever, and the way we would usually do this mathematically is to put a bar above that last three, or just even one of them, because math nerds would say, well, that's not simplified. You'd just do 1 3 that repeats like this, okay? But the bar indicates that that number will repeat forever and ever and ever. It will never stop repeating. Now, that's just with one number. There's not really any other real famous ones in my mind, but it's possible that you can have like 2 numbers repeat. Like if you wanted just the 2 and the 5 to repeat, you can't. If you wanted 3 numbers to repeat, yeah, you can put it over 3 numbers. Then those 3 numbers will repeat forever and ever and ever. Okay, so those are repeating decimals. A terminating decimal is a decimal that stops eventually. Now, technically, it doesn't stop if you want to, talk to math nerds about that. But a common terminating decimal would be something like 0.5, like this. Another common one would be 0.25. Now, I'll read those two out mathematically, right? That's 5/10, that's this one. And this one would be 25/100, it's this one. Now, the reason why we say they terminate is because we don't actually have to show the numbers that do repeat. But there is a number that repeats. You just can't see it. And we don't usually like to show it because it's a repeating 0, like this. So technically, there's a bunch of zeros that repeat. You can put a bar above it. But usually, we just don't like to show it at all. Okay? And the same is true for the 25/100. There's zeros after it. We just don't like to show those. And that way, it terminates. Now, the repeating decimals, it is possible on the assignment. You may see it something like this. So you may see something like 0.1, and if the 1 repeats, they may just do 3 dots after it like that. That mathematically isn't necessarily how we like to show a number repeats. You'll usually see the bar notation like I've shown, but you'll see it on the assignment where they use the 3 dots instead. So a rational number it usually is shown as a decimal. We'll talk about the square root thing later on in the lesson. But an irrational number is a decimal that goes on forever and ever and ever, but does not repeat. So a famous irrational number is shown with this symbol. That's pi, which my understanding is Greek for p for parameter. But I could be way off on that because I don't know Greek. Okay, another one that you probably haven't heard of as much, but I guess math nerds and scientists know about is E, which is Euler's constant. So if you put these, you can find both these on your calculators. If you were to put them in, it would give you a really ugly decimal. That's because the calculator is saying, I don't know what to do with this ugly decimal, because it goes on forever and never repeats. So you may just see something like this. Now, here's the other thing with the 3 dot thing. So you may see even it could be negative 4.102587113. You see what I'm saying? Like this This is a pretty ugly decimal. It's so ugly that it looks like it doesn't repeat, and if it doesn't repeat, what they'll do is they'll put 3 dots at the end of this. But there's usually some kind of obvious way to see that it's so ugly that they're just putting this on here to show that the decimal goes on forever but does not repeat. And that's the danger of showing the 3 dots like I've done right there. Which is why we like to show bar notation for repeating decimals, okay? But if you were to find an irrational number on your calculator, it generally looks pretty ugly like this one. Now, there are some fractions where if you change them into decimals, they look pretty ugly, and they do repeat, and the calculator, there's so many decimals that do repeat that the calculator will not show you. But I don't know that we'll see many of those, because we don't want, while we're getting used to this, we don't want you guys to have to do the division and then have to do so much of it, because it gets a little painful if it gets too long. So the last thing here is, again, on the assignment, they're going to show you a number. They're going to say, is this rational or irrational? And you have to know the difference. So changing decimals into fractions. So if you have a decimal, okay, you can see that each of the place values tells you something about the fraction, okay? Specifically, the denominator of the fraction, but you have to know the place value of the number furthest to the right. So, if by chance we end up with mixed numbers, as we can see, the whole values are going to be any value that is to the left of the decimal. Okay, so if they give you like 1.5, you know you have 1 and some fraction. Okay, so for example, 1.5 right there, I would just say right off the bat, changing this into a mixed number, I'd have 1 and then some kind of fraction right here, where I would fill in the numerator and denominator. Okay, now we'll talk about how to fill those in, but if you ever see anything to the left of the decimal, just make it the whole number in a mixed number, even if that number is negative. So if that's negative 1.5, then just make it negative 1 and some fraction like that, okay? So if it has a negative sign, let it keep the negative sign. If it's positive, well, just keep it positive. But this is going to reduce the amount of work we need in order to change a decimal into a fraction, because some of them are not just going to be straight decimals. Some of them are going to be mixed between the whole values and the decimals like this. Okay, so here's what we do is we're going to create the fraction ourselves here like this. The denominator will be the place value of the number furthest to the right in the decimals. Now this one, of course, is fairly easy because the 5 is one place value to the right of the decimal. It is in the tenths place value, which means that the denominator there will be 10 to start out with. Now some of you may know what this mixed number would be actually. That's because when we get the full fraction together, look to simplify. Okay, but always look to simplify, even though sometimes it will not be. It's just most of them that they give us do require some kind of simplification. Okay, so I have a 10 denominator because the 5 is in the tenths place value. Okay, well, how many tenths are there? There's just 5 in this case. So I put a 5 here, and then I would reduce the fractional part of that, so you keep the whole number a negative 1 there, but then you'd say, well, I know I can take 5 and divide it by 5 because 10 is also divisible by 5. Then you'd make that, and this is probably what you may have been thinking, 1/2. Okay, so it ends up being negative 1 and 5/10 ends up being negative 1 and 1/2. But notice the way that we read this mathematically, negative 1 and 5/10, that's the same way that this one reads. That's negative 1 and 5/10. But we reduce, as a mixed number, we reduce that fraction. Always look to reduce that fraction, okay? So it says the numerator is the entire number without a decimal. Again, that's only the decimal portion of the number, so long as there's not a 0 whole number right there, okay? Okay, so this one, I'm not going to make it a mixed number because there's no whole values to put into my mixed number. This is going to come out as a proper fraction. And just to start out, I'll start with my sign just so I don't have to worry about that garbage. but it's negative. So whatever fraction I get, which I'm setting up there, it will be a negative fraction. So I put my negative out so I don't have to worry about negatives anymore. That part's done. Okay, well, in this fraction, on this one I'm going to start with the numerator, because the numerator is going to be whatever this number is, just no decimal. And I would read that as 38. That's 38 right there. Okay, now I know that's 38. It's actually 38 hundredths. So we'll even write that in, hundredths, just like we did in the last lesson. But the 38 part is going to be the numerator. So here I say in my fraction I have 38, and there are 38 of the hundredths. So the denominator will be hundredths, like this. Now the reason why I didn't write this into this fraction is because I'm anticipating simplification in this fraction, okay? So when I simplify this, then I'll kind of fill this in as my final answer right here. So I look at 38 and I look at 100, and I say, well, I know these, at least they're both even, so I should be able to divide them by 2. Let's see how that works with just division by 2, and then if we can reduce more, then we will. So I'm going to say 38 divided by 2. Yeah, very good. So I'll still do the long division here. So 2 goes into 3 once. 1 times 2 is 2. So we used up 2 of the 3. We got 1 left over. Drop the 8. 2 goes into 18 9 times. That's 9 times evenly, so there's nothing remaining. That's what we want. So my numerator is 19. And again, I'll show the division for the 100. I know not everyone needs it, but it's good practice. Okay, so 2 doesn't go into 1, but it will go into 10 5 times. 5 times 2 is 10. Nothing there. And so 2 goes into 2 zeros, just as many zeros as you want. 0. So our denominator ends up being 50. Okay, so now we can look and say, well, I know they're not both even. 50 is divisible by 10 and 5, but 19 is not divisible by any of those. In fact, 19 is by itself prime. So 50 is not a multiple of 19, so that's as reduced as we're going to make that, which means our final fraction ends up being negative 19 over 50. That is reduced. So I'll emphasize this because it's one of the things that a lot of students miss when they do this. They say, well, I know it's 38 hundredths, and then they'll write this fraction, and that's a great start, but it's not fully reduced. Please do not forget to reduce all of your fractions when you can. This is why that stuff we went over in 6.1 is so important, because now we're seeing that knowing the place values, like we've done here, is crucial. And knowing how to even how to communicate this in words, you can see it kind of spells out the fraction for us. So if you can do that, then converting your fractions and decimals into fractions should be, it should be, I wouldn't say easy, but doable. There you go. All right. I'm not gonna say what this one is. I'm not gonna read it. It's negative 0.464. Okay, but the real reading we'll do later. Try this one out and see how you do. Okay, so once again, we're going to start with the negative here. So I know that the fraction that I end up with is going to be negative. So I'm going to just set up my final fraction right there. Now, I would look at the decimal here, and now we will read this mathematically. That's 464 thousandths. So I'm going to write this out. 464, that's in thousandths, like this. Okay, so I'm going to set up my fraction. Again, I know it's going to be negative in the final answer, but I don't really care about that right now. As of now, this is 464 right there. So that's going to be my numerator, 464. And the denominator will be the place value furthest to the right, which is this 4, and that is in the thousandths place value. But again, just by communicating that and writing it down, that it kind of told us that it was in the thousandths. Okay, so from this, once again, I see that both of these numbers are even, but I want to say 464 should be divisible by 4. So I'm gonna try that out. Let's see how that goes. I know 1,000 is divisible by 4, but let's try 464. Divide that by 4. Let's see how that goes. 464. And we're going to divide this by 4. 4 goes into 4 once. 1 times 4 is 4. That's used up. Drop the 6. 4 goes into 6 once. 1 times 4 is 4. So we got 2 left over there. Drop this 4. 4 goes into 24 6 times. So nothing remaining on that. So that ends up 116. And then we'll do 1,000 also divided by 4. So 1,000 divided by 4. 4 does not go into 1, but it will go into 10 twice. 2 times 4 is 8. That's 2 left over. Drop the 0. 4 goes into 25 times. And 5 times 4 is 20. Nothing remaining. 4 goes into 0 times. So we end up with 250. Looks like I didn't divide that enough, because I can simplify these just a little bit more by dividing them by a 2, which I think we saw when we put these into the calculator. Okay, well, let's see what that gives us. So now we'll do 116, but divided by 2. 2 doesn't go into 1, but it will go into 11. 5 times 2 is 10. 1 left over, 16. It's 8 times. So that ends up being 58 numerator. And then 250 divided by 2. 2 goes into 2 once. 1 times 2 is 2. Nothing remaining there. Drop the 5. 2 goes into 5 twice. 2 times 2 is 4. Got 1 left over. Drop the 0. 2 goes into 10 5 times. So that ends up being 125. Okay, 125 is not divisible by 3. Neither is 58. 125 is divisible by 5, but not 58. I think that's one that we got, right? So that's end of, that should be our final answer. 58 over 125, but negative. And that should be good. That's it. Change this decimal into a mixed number. Now, the first thing I notice, it is negative, but I've got a negative 5. And since we have a 5 in the ones place value, there's a whole value as part of this. So as part of my mixed number, I know that the first part is just going to be the negative 5, and then I'll tack the fraction on as we go. Now that means that the 5, this negative 5 right here, when I consider the fractional part, I don't use this as part of the fraction, right? It's part of the mixed number, but not the fractional part of the mixed number. What I do consider is the 55 part of there in order to make the fraction. So just like we've already done, we would say I'm going to make this fraction, and then this would read, just the decimal part of that is 55, and that would be hundredths. There we go. There we go. Okay, so that's 55. That's going to be my numerator. And the 5 to the right is in the hundredths place value, which we also said right here. So that's going to be our denominator. Okay, well, that's going to help us to simplify this as a fraction, which we will now do. And I see I've got two numbers, one ending in 5 and 0, so these are both divisible by 5. And 55 divided by 5, that's within our range of multiples we should know. 55 divided by 5 is 11. 100 divided by 5, that may be a little bit more tricky, but if you know it, that's fine. I'm still going to show the work. I'm going to do 100 divided by 5. 5 doesn't go into 1, but it will go into 10 twice. 2 times 5 is 10. Nothing there, nothing in the ones, so it will go into 0. 5 will go into 0 exactly 0 times. And we end up with 20. So our final fraction for the mixed number, we have the negative 5 already, but now we have also 11/20. And that would be considered fully reduced. 11 is prime, so, and 20 is not a multiple of 11, so that's as simplified as we can make that. So truthfully, this is just more of the same. stuff that, like the last two examples we did, but now there is a number out here in the front, just like we showed in the original example. Now this decimal is a little different, so be careful. But try this one. Take this decimal and change it into a fraction. Now it says fraction. We see the whole value. I'm just sorry to kind of give you guys little guys here, but it's going to be a mixed number. Just plan on a mixed number. Try it out, and then we'll go over it. So to start out here, we've got that negative 29 and 305 10,000ths. Okay, so once again, I'm going to change this to a mixed number. I know it says a fraction, but we can qualify that as a mixed number. The negative 29, just the whole part of the number. Any numbers to the left of the decimal, we'll just write it out as the whole part of the mixed number. So I've got negative 29, and then we're going to have some kind of fraction over here. And this is where we need that decimal written out. So I'm going to do that. That is 300. And it's not 305, it's just 305 mathematically. And that place value is the 10,000ths. Okay? So, once again, I set up a fraction. So yeah, that's going to be, that just reads 305. Again, I don't care about this 0 right here, although it does help me with the place value. It's going to be 305, and like we've already written out, this 5 to the right is in the 10,000ths place value. So that's going to be my denominator, 10,000. And I'm looking at the same situation as last time. I got a number that ends in 5 and 0 in the ones place value. So these are both divisible at least by 5. Okay, so let's do the math here. Let's simplify these. Start with the 305. And we'll divide that by 5. So 5 won't go into 3, but it will go into 30 6 times. 6 times 5 is 30. Nothing remaining there, so we'll drop the 5. Put the 0 there if you like. 5 goes into 5 once. Exactly. So my numerator, 305 divided by 5 simplified, is going to be 61. Next, we will do 1,000. That's 10,000. 10,000 divided by 5. So 5 won't go into 1, but it will go into 10 twice. 2 times 5 is 10. So we don't have anything remaining there. So in the hundredths place value, there's 5 goes into that 0 times, and those 0 times, and these 0 times. Yeah. Yeah, so that ends up just being 2,000. Okay, then I would look at this. 61 is not divisible by 3. It's not divisible by 7. It might be prime, but I know that 2,000 is not divisible by anything that 61 is, except 1. So that would end up being the fractional part of our answer, 61 2,000ths. So our final mixed number ends up being 29 and 61 2,000ths. Boom. That is all. The grid below is the unit, and each rectangle is 1/10. So here's your tenths. Of course, 10 of them makes up a full unit. So that's why they're saying the full grid is a full unit. Mark a single dot at each corner to outline and shade the area that represents 4/10. Okay, now since each of these is its own tenth, right? Like this is the 10th right here. This is another 10th, and this is a 10th. We only need 4 of them, right? So I'm only going to mark 4 of them. There's 4 of the 10ths right there. So what we need to do is we need to box in a rectangle that covers this area right here. So I'm going to do this. I'm going to do it with a little technology, though. Let's see if we can make this pretty. So mine is going to look something like this. Now, again, the trick is when you put this into the assignment, okay? So it says you got to put dots in each of the corners. So in the past, from what I remember, you have to put a dot first in the, well, that's the origin, but it's in that lower left corner. And then I don't think you have to drag it, but then you just click on this corner up here, and then you'll click on this corner and this corner right here. I believe once that's done, then it's complete. But
Are we doing it on computer?
the trick is, some students, in order to finish this off, sometimes they'll click on this one twice, the one they start with twice. Don't do that, because it says it just wants a single dot at each corner. So even though it will only show one of the dots, if you double click on the same spot, it'll be two dots, and then the computer will be like, what the crap is going on? And then it'll mark it wrong, even though the rectangle is showing correct what you've shaded in. So this one now is in hundredths. So the grid is one full unit. They're 10 by 10 grids, so there's 100 squares, which is why we're dealing with hundredths here. Mark a single dot on each corner to outline and shade the area that represents. Again, this is where it becomes crucial for you to do it this specific way, because if you don't, then it will mark it incorrect, okay? So first off, I'm gonna start with the 70 part. Okay, so that 70 would be 7, you can say 70 or 7/10, right? So I'm just gonna look at 7 bars. So that'd be 1, 2, 3, 4, 5, 6, 7 right there. I wouldn't mark anything yet on the assignment, right? Okay, but if I'm gonna do this, but again, it's not what my final answer is gonna be. I'll show you how to do this with the dots, but you'll end up, you're gonna want some of this part of the rectangle. Again, don't put any dots yet, because we still have these 3 as well that we need. Now, the 3 that you need are at the bottom of the next bar, which for me is gonna be these 3 right here. Now, let me see if I can clean that up. There we go, that's pretty. Okay, now, again, what you need is to click on each corner of what I have here in order to make what would be a correct answer. What you do not want to do is separate these like I have here. The only reason I have these in 2 different colors is so we can see how many we needed, right? We needed 70, that's in the red, and then the 3 last ones in purple. So you're gonna click on, again, you'll click on this bottom left corner. You're gonna use all 10, 7 of those. Now, what you're gonna do is you're gonna need to click on this corner, and then this one and this one. You're not gonna click here, right? We don't really care about this one, but we need this corner. And so once we click here, then it should kind of finish that off for us. So I would say we need this one, and this one. Once again, if you were to shade these 3, even though it is correct, it will mark it wrong. It needs the 3 bottom ones in order for you to get credit. Once you do that, it should finish off the full rectangle, and then it'll look pretty, something like that. And then it'll put the lines there for you, and then it'll shade it in, and it'll look pretty. But again, I'm using the 2 different colors so we can see which ones we needed. Another mistake students make on this is they'll do 7 rows, and then they'll do like the 3 top ones. Again, it is correct, it's just not what the computer wants. All right. So we did decimals, we wrote the decimals as fractions. Now we need to be able to write our fractions and mixed numbers as decimals as well. Okay, so what we're gonna do is, if there is a whole number part of the fraction, fraction or the mixed number really, then we will we'll keep it, okay, in the decimal, which we've seen. If it were some kind of, let's say it wasn't a mixed number, let's say it was just an improper fraction, then what you end up with is some kind of quotient here, and that would be your whole value there. On the other hand, though, we are going to be using long division in order to change the fractions to decimals. The problem is we're expecting to have a decimal in the decimal, okay? So what you're going to do is, once you get down to the ones place value, it'll be the number placed, the place value furthest to the right. What you're going to do is you may have to it may require you to extend that long division line like I've done right there, and then you'll have to put a decimal into the number yourself, and that translates up into the quotient as well. Just like we saw last time with, we did a little addition with the decimals, but make sure your decimals are lined up in long division like this. Now, some students are like, well, yeah, but there's nothing to divide with over here. There is, you just can't see it, and if you need those values, you're just gonna you're gonna tack in zeros like this. Now, are you gonna need 5 zeros like I put in there? No, we don't know how many zeros you're going to need. Just start with 1, and then as you need more, just expand as you go. Okay, so that's why in 3 here it's saying show phantom zeros to expand the numbers if there is more remaining. Okay, and then whatever this is will be part of your answer. What you may find though with this long division is that you'll see sometimes there's a pattern with the division, and if there is a pattern, it usually means that there's a repeating value in there. Or repeating values, which means it's a repeating decimal. We'll see. If you look at a fraction, if you look at a fraction like we've done before, a fraction line by itself is a division sign, which is why we change these fraction divisions into long divisions instead. So let's start with this one. So that's -1/8. Okay, now the decimal on this one, the decimal is going to be, it's going to be a negative decimal, so I've got my negative and then I've got my decimal here. I'll fill in the blanks as we go. But what I have in my numerator is a 1, and then we're going to divide this by the denominator of 8. Now, as we've seen before with division, and be careful because some students, since they want this to work without the decimal, they'll switch these, which we don't want you to do because that would be incorrect. Okay, so the problem here that we run into is that the 8 is too big for the 1. So I put my 0 there on purpose because it won't go into 1, but what we're going to do is I'm now going to make that 1 a decimal with a 0 in the 10th place value. I want this 0 here. And instead of looking at this, well, it's a dividend as 1, I now look at it as 10. And I say, well, 8, yeah, 10 is big enough for 8 to go into. Okay, so now that I have my decimal, I'm gonna translate that up here. Again, they need to be lined up. But now I'm looking at this as 10. Well, how many times does 8 go into 10? I got 1 time. So, doing this regularly, 1 times 8 is 8. Now I'm working in this place value, and we'll subtract that. Again, I would look at that as 10 minus 8, which is 2. Now, we've gone into a decimal here, but again, I've got a number that's too small for 8 to go into. The 2 is too small for the 8. So what I'm going to do is I'm going to tack on another 0 to the 1, and then I'm going to drop it in order to make that number a 20. So 8, now that I'm looking at as 20, 8 will go into 20 2 times. Now 2 times 8 is 16. When I subtract that, I'd make that 10 minus 6, which is 4. 1 minus 1 is 0. And now I've got a 4. But again, 4 is too small for the 8 as well, so I'm going to tack on another 0 and drop it in order to make this number bigger into a 40. Well, yeah, 40 is great because it's a multiple of 8. 8 goes into 45 times, exactly. 5 times 8 is 40, nothing remaining. Which we shouldn't get anything remaining when we're working with the decimals. If there is, then it should be some kind of repeating decimal. Now, you could say, well, 8 doesn't go into 0, and you could tack on another 0 here, and this is kind of what I was talking about before. How many times does 8 go into 2 zeros? Well, 0 times. And if you tack on another 0, how many times does 8 go into 3 zeros? Still zeros. But you see that the 0 now repeats. But instead of showing those zeros, we're just going to kind of get rid of them and show that it now terminates. Just like you would show that it terminates by getting rid of this garbage. Okay, so my decimal, and I'm going to show the 0 here just because it's good math etiquette. But I don't think you necessarily have to. So my final answer ends up, remember, was negative. So it's -0 and 125 thousandths. There we go. -125 thousandths. Done. Now, some students look at this and they're like, well, you changed the number. It used to be a 1. Now it's a 1,000. No, it's not 1,000. It is 1,000 thousandths, though. And that's what this is. It's still a 1, it's 1.000, and that's okay to do that if we need those zeros. And like you saw, you can tack on more zeros if you need to. We just didn't need to in this case. Okay, now this is 1/15. We're going to change this to a decimal. You're going to try this out, see how you do. And if you notice anything different about this one, which you should, that's okay.
Add an extra 0?
All right, well, let's get started here. So that's that would read 1 over 15 as a fraction, but it's really a division sign right there. So that's what we're going to do. We're going to take the 1 and divide it by 15. Okay, and just like the last one, well, 15 doesn't go into 1. So I'm going to make that a decimal, tack on a 0 there, and then I'll line up the other decimal in my quotient. This one's not negative, and that's okay. But the problem here is that 15 doesn't go into 10 either. So I'm going to tack on another 0, and that's okay if that happens. It will happen from time to time. Then I'm going to tack on another 0. Now I'm looking at this as 1 to 100. And you can see over here on the right, I've kind of put together a 15's multiplication table, which I will do if it's a number beyond our multiplication tables that we should have memorized. So I know 15 will go into 100. It only goes up to 90. That's my 1, 2, 3, 4, 5, 6th multiple. So 15 will go into 100 6 times, though not exact. 15 times 6 is 90. And then when I subtract this, 0 minus 0 is 0. And 10 minus 9 is 1. Now you see I've got another 10 here, right? And we've already seen a 10. So what I'm going to do is I'm going to tack on, and again, this becomes kind of a part of a pattern here. I'm going to tack on another 0 to my decimal and show this as 100. I'm back to 100 again, right? Remember we had this 100. Now I'm back to 100. Looks like the 0 is not going to be part of the repeating process here, but 15 goes into 100. Well, we've already seen it goes into it 6 times. 6 times 15 is 90. I don't need to do the subtraction because it's already been done. I know that I'm going to end up with 10 remaining on that, okay? So that's from the subtraction. Now, here's the thing is I have a 10, or I had a 10 remaining, and then I've got another 10 remaining, and this is going to repeat. So if you tack on another 0, of course, you can say, well, I can do this 6 times. 6 times 15 is 90. And now when you subtract that, well, you're going to have another 10 left over. And if you're to do this again, you could do this as many times as you want. And what you're going to end up with is just a bunch of 6s repeating forever and ever and ever. Now, again, it's important to notice that it's the 6s that repeat and not the 0. This 0 in the decimal place value is important to notice that it does not repeat because sometimes it will. And so I'm going to write this answer as a decimal. Okay, so here's my decimal. It's 0.06. To show that it repeats, I've got my bar notation there, and that's good enough. Now, if they were to say something like, round this to the nearest thousandth, like this, you'd have 0.067, because this 6 is 5 or more, so it would add 1 to this 6. So just be careful. Just doing it on paper, I'm going to show it with bar notation. But again, I'm forgetting if they say that you need to do any rounding on this assignment. Okay, so let's do this one. Let's change this one into a decimal as well. Now, this is a mixed number, and that's good news because as a decimal, the whole value is, well, it's still the whole value. So the -6 whole value is just the -6 part of the decimal. It's the whole value of the decimal. So we tack that in, and you don't have to worry about changing that into an improper fraction. I think that's great news. But what we do need is to be able to take that 2/11ths and change this into a decimal. So this is where we, of course, the fraction line is a division sign. So we would write this in as 2. See if I can do a better long division sign. 2 divided by 11. Now we should have our 11 multiples up to 9 memorized, but if not, that's okay. You can make a multiplication table. I'm not going to. I know 11 will go into 2, so I'm already planning right now to tack on a 0 here. 11 does not go into 2. What do you know? But it will go into 20. If I have this down as 20, 11 will go into 20 once. 1 times 11 is 11, so when I subtract this, 10 minus 1 is 9. And 11 doesn't go into 9 because it's too small, which is kind of part of the plan there. So I should have expanded that line. Let's drop another 0 and make that 90. Okay, well, 11 will go into 90 8 times. 11 times 8 is 88. And when I subtract this, I've got 2 remaining. Now, whether you notice anything or not at this point, I'm just gonna skip it because I'm gonna address it later. So I'm gonna drop another 0 here and make that 20. 11 will go into 20 1 times. 1 times 11 is 11. When I subtract that, which we've already done, we get 9. Okay, well 9, I'll tack on another 0 here. 11 does go into 90 8 times. 8 times 11 is 88. Now this is important as math people. After I do the subtraction, I get 2, right? Hopefully you see the repeating pattern here, right? We started with 2, we had a 1, we made it 20. 2, 9, 2, 9, 2, 9. So this pattern is going to repeat. 2, 9, 2, 9, 2, 9, 2.
It's just negative 16, 1, 8.
So it's going to repeat, and so we can anticipate that you would have 1, 8, 1, 8, 1, 8, 1, 8, right? Which means the 1, 8 repeats. So in my decimal, I've got negative 6 and 18. It's not 18 hundredths because it repeats. I would just say it's negative 6.18 repeating. And that's good enough. That is the part we need. But again, if you see a mixed number like this, just tack that whole value on as the whole value of the decimal, and then find your decimal by dividing with the fraction. I only cycled through this twice. If you need to cycle through this more like I'm showing up here, like if you needed these numbers to show that, oh, I can see now it repeats, and that makes you feel more comfortable that you know it repeats, do as much long division as you'd like or need, I suppose, because not anyone likes long division. But do it as much as you like until you feel like yeah, I know this repeats, I just needed a lot of them, and that's okay too. Okay, now this one is an improper fraction, but still try it out. See how you do, and then we'll go over it. So we have, we're going to change this into a decimal. It is an improper fraction, but the long division is still going to help us change this into a decimal. It's just, we're going to expect something to the left of the decimal. So I'm going to make this 31, see if I can do this, 31 divided by 9. Now I'm anticipating a decimal because 31 is not a multiple of 9, so I'm anticipating this decimal right here, which again I need to make sure that it's lined up with the decimal in the quotient here. So I don't need multiples of 9 because that's multiples we should know. But I know that 9 does not go into 3, but it will go into 31 3 times. 3 times 9 is 27, so when I subtract this, we'll make that 11. 11 minus 7 is 4. Now, I don't need to bring the decimal down into these values because I'm going to be looking at these as just values. But 4 is too small for 9, which is what we would anticipate. Otherwise, we did the multiplication wrong, or we found the wrong multiple. And then we'll just tack on a 0 there into the tens place value and drop this and make this number. Now, instead of 4, it's 40. In fact, I probably should have color-coded that 4 right there. So, how many times is 9 going to 40? I get 4 times. 4 times 9 is 36. And when I subtract that, I get, going to be 310 as 10 minus 6 is 4. Now, we've already seen the 4 in purple there, so you can see when I drop another 0, I get 40, and 9 goes into 40 4 times. 4 times 9 is 36, and when I subtract this, I also get 4. So we see the 4s are repeating as we go, which means we would anticipate the next value to be another 4, and we can prove that it would be by tacking on another 0 and dropping it. 9 goes into 4, what do you know, 4 times. So you would have subtracted another 36, and then you would have another 4. Yeah, so we just end up with repeating 4s right here.
So we just get 3 points.
Well, it's going to start out as 3.4, so there's my decimal. I've got 3.4, but again, the 4, since it's going to go on forever, it will repeat forever. We're going to show that 4 with a bar. So we're going to say that's 3.4 repeating, but it is not, and this is where we got to be careful on that. We need the bar. It is not 3 4/10. It's 3.4 repeating. Like I was saying, this is one of those that's just going to be on the assignment. We're going to go over this one just so you can see how to do that, whichever one you get on the assignment. So we want to approximate the fraction 3/9, which has a repeating decimal in the grid above, but it's below for us. You shaded 3 out of the first 9 columns yellow. Next you shaded 3 out of the first 9 squares in the 10th column yellow. Guess that's these 3. Finally shaded approximately 3/9. That looks like it's this blue one. You have a 100th square in the corner blue. So how many small squares are shaded yellow? So the yellow ones, of course, we've got these 30 here. And then in addition, we've got these extra 3. Those are the yellow shaded ones. So to answer that first question, we'll just write this in as how many small squares are shaded yellow. There's 33. I put those in different colors on purpose. That is the same as, because each square is its own 100th, that's the same as 33/100ths. Now, if you wanted to show that as a fraction, of course, that'd be 33/100. We're looking for the decimal part of this, so use your answer from part A to round 3/9 to the nearest tenth. Notice we don't really care about this blue one, because that 33/100ths as a decimal would be 0.33. That's 33/100ths. And if we wanted to keep that color-coded, you have 3/10ths and also 3/100ths. Now this part B says round to the nearest tenth, which is the 3 in red. So to the right is less than 5, so we're just going to keep that 3 in the tenths place value a 3. So rounded to the nearest tenth, we got 0.3, or just 3/10ths. Rounded, of course. So that's parts A and B. There's 33 of the yellow shaded boxes, which ends up rounded to the tenth is closest to 3/10ths. So part C, is the portion of the cell shaded blue greater than or less than 1/2? We can check this. So I'm just going to take this and I'm going to kind of blow it up here. So let's, otherwise it can get kind of jacked up. There we go. That's hopefully fairly visible. Now, if you were to ask me, I'd say that the halfway point would be about right. Well, that's about as straight as you're going to get from me. It's definitely less than 1/2. So on this one, we're going to say it's less than 1/2. Okay. Now, the reason why it's important to know that it's less than 1/2 is because that means that even though we know we got 33/100ths, the next value is going to be less than 5. So if this shaded box is less than half, then this next number here, which would be in the thousandths place value, is going to be less than 5, which means that the number itself is going to remain 0.33, or that the number, if we were to round it to the nearest hundredth, even if we knew what it was, would still be 33/100ths. That's rounded. If this blue part had gone beyond the halfway point for some reason, then it would have been, then we would have had to have added 1 to this. That's the rounding part of it. Again, we don't really need to know what this number is. We could do the division and find out. It's a 3, by the way. But we don't really care in this context. Okay, the next part, comparing and ordering decimals. So just like we did back in, I think it was Unit 1, we're going to stack the numbers according to place values. We're specifically going to line up the decimals to help us with the place values. That's it, okay? Then, after having all the numbers in a stack, we're going to scan the numbers from left to right, comparing one place value at a time, seeing which ones are equal or which ones are not equal, and noticing which ones are bigger by specific place values. Now, from the left, if you get numbers that are bigger on the left, they're automatically greater. Numbers that are, and then you scan going to the right, okay? So we'll place these in order, usually from biggest to smallest, which is why we scan from left to right. So this one says, place a less than, greater than, or equal sign between these two decimals in order to make the statement true. But once again, what I'm going to do is I'm going to take these and stack them. Okay, now notice I've lined up my decimals. That's on purpose. And then I scan these from left to right. I don't care if any values are missing. If there are some place values that are missing, if you would like, you may tack a 0 onto it. Okay, and that's true going to the left or the right. So if you wanted to tack zeros on over here, you could. I'm not going to do that though. Okay, so I scan this from left to right. I'm just looking, since I'm only comparing two numbers, we just got to find which one's bigger. So again, in the ones place values, the zeros, okay, those match. The next place value is the tenths place value. Those are 4s and they match. Here, in the hundredths place value, I get non-matching numbers. Now that means that I don't really care what's to the right of these when I'm only comparing two numbers. I don't care about the 607 or the 070. I don't care about those. The only thing I care about is these. And what do you know? Between the two, the 6 is definitely the bigger of the two. So that came from 0.4607, which is this number. It's bigger, which means that it needs to be eating that value. So this would be 4,607 10,000ths is greater than 40,607 100,000ths statement. There we go. But it's definitely bigger, okay? Now, not everyone necessarily needs to stack, but especially when you start comparing more numbers, be careful because a lot of students, they may miss this 0 or they may say, well, there's more digits on this one, so it's definitely bigger. That's not the case, just like we saw, which is why I highly recommend that whether you feel comfortable doing this or not, stack these and just compare. But stack and compare will give you a lot more accuracy than just eyeballing it. All right, so I've got negative 8 and 55 hundredths and negative 8 and 559 thousandths. Again, just replace that or put a symbol between there, less than, greater than, or equal to make the statement true. Try it out. Let's see how you did. So again, I'm just going to take these numbers. I'll do it over here on the left. Now again, it's important to have those decimals as lined up as possible so that we can compare specific place values. So to start out, we've got the 8s. Those match. Since they match, I need to move further to the right. Next up, I've got 5s that match in the tenths place value. But even the hundredths place value, we have matches. So what I'm going to do is I'm going to take a 0 on to the next place value in the thousandths. And what do you notice? Now we have non-matching values in the thousandths place value. This will tell us which one's bigger and which one's smaller. Now the 9 is definitely bigger than the 0, and that comes from this number. And a mistake that we see often with students is they say 9 is bigger than 0. Boom, it needs to eat the 9. The problem with this one, these ones are negatives. So you got to be careful. If you see the negative marks, you need the smaller of the two because we want less negatives, or the less negative it is, the bigger its value is, I guess. So it is definitely not a less than symbol here. It ends up being a greater than symbol instead. But now notice, if these had matched here, let's say these were 9s for some reason, then you could put an equal sign as well. So sometimes they'll just match all the way through. Then you may need an equal sign. The 2 we did, of course, were both greater than, I believe, but be careful if these are negative. The bigger the bigger number would be the lower of the two place value when you compare the place value. So they're going to give us lists of numbers. We got to list these in order from least to greatest. Once again, what I would recommend doing is just placing these numbers stacked, lining up that decimal. So let's stack these by the decimal, which again, just having the decimals line up automatically places these or stacks them in place value, by place value. So I know that's not perfectly lined up, but that's good enough for me. So we go from left to right, and this one wants it, it says least to greatest. That's a little unusual. They usually want, no, least to greatest seems right. So least to greatest, right? So I first look at my, my place value furthest to the left, which is the 1s. The 8 and the 9, we're going from least to greatest. So we want the lowest value first, which is either of the zeros. Now those zeros match, so we're going to just focus on these two. We'll come back to these two later. But for now, let's just focus on these. And the next place value is 9s, and they match as well. So that means we need to go even further to the next place value, which is an 8 and a 0. Now, again, we didn't need this 8 or to put a 0 here because now we have non-matching values. Now, since we're going from least to greatest, that means that this one right here is less because 0 is less than 8. Now, that came from this number here, so we're going to, in order from least to greatest, we now have this number first as the least number. And since we were comparing specifically with 0.98 or 98 hundredths, we're going to take that 98 hundredths and we're going to list that second. We'll put a comma between them. Okay, and now that we've used those in the list, I'm going to cross those out just so we know not to worry about those anymore. You could even just kind of scribble them out if you'd like, or some students even like to just take them and, kind of just cover them like this, whatever. All right. So now we're just comparing the 8 and 9 hundredths, and then we've got 9 and 808 thousandths. But back here in the ones place value, the numbers we started with, they're already different. The 8 is smaller than the 9, which means that we don't need to compare any other place values between those two. You've got 8 and 9 hundredths, and then you've got 9 and 808 thousandths. So that places all four numbers in order from least to greatest, and that's what we want. We've done this type of comparison before. I think it was in Unit 1, Module 1. But there were no decimals, right? So back in those days, we didn't really need to tack on any values. Like we didn't. Here you can put a 0 there, but in that unit, you wouldn't be able to do that. So again, just line up the decimals, compare numbers from left to right. And since we're going from least to greatest, start with your least, move to your greatest. All right, so again, we're going to do this one. Try this one out. Again, arrange the order of the numbers in order from least to greatest. So again, you're going to want to stack these. There's no negatives, and that's kind of, I don't know. I expect to see some negatives, but no negatives. That's okay. Again, we know how to compare negatives from less than, greater than, equal to problem. But try this one out, then we'll go over it. Okay, so I've already lined these up, lined them up. So I just listed from left to right, top going down. Now we notice in the ones place value, these are all zeros. So we can move on to the next place value, the tenths, and we have a little differentiation. We got zeros and fours. So what I'm going to do is I'm going to take these and just kind of rearrange them. I'm just going to take these two and switch them. Again, it's not necessarily in order from least to greatest. I'm just switching these so that those zeros and fours are separated in those place values. Now we have that comparison, which is important because we have differences in there. So these two are definitely bigger than these four because 4 is bigger than 0. So since we're going from least to greatest, we have the least ones down here. And just between those four that we have, let's compare the next place value. So that would be these ones. Okay, now again, there's a little differentiation. We got 4s and 0s. So what I'm going to do, let's see if it'll let me do this. Just kind of switch them on my own, okay? Now, even though the 4's on bottom, that's okay. 4s are bigger than 0s, so I've got the 0s to compare. And so I'll move to the next place value, which is, with those two, it's the 3 and the 8. Okay, now 3 is definitely smaller than 8, so it would be the least. So I'm going to take 0.003 or 3 thousandths. This would be my least number. And then the 8 thousandths would be the next least number. That seems to work. Okay, and we've used those two numbers up. So I'm going to scratch those out. Now, since we're still comparing the zeros in the tenths place value, let's go to these two. So the 4s match, and I am going to tack a 0 onto this bottom number to make it 40. And now when we compare these, I'll try to use a different color. 3 and 0. 0 is definitely smaller than 3. So between these two, the smallest would be 4. Well, I guess it's just 4 hundredths, which came from this number furthest to the right here. That's this one. I'll put in my own comma. And then the 43 thousandths would be next. It's this one. Okay, and now we've used those two up. So we're back here comparing these fours, and we'll move to the next place value, which we'll compare. Let's see if I can do this. 0 and 3. Well, those are a direct comparison. I don't really need the 7 or what would be a 0 here. 0 is definitely smaller than 3. And so we're going to take that number. That's 407 thousandths from here. And then the biggest number was the 43 hundredths, which is right here. Okay, and that's all the numbers in order from least to greatest. Yeah, we use these top two as well, so just cross those out just so we know we used them. And now this list is in order from least to greatest. Done. Okay, square roots. Now we'll be using a calculator for a little bit of this, but what we're going to need, so we have all of our multiplication tables memorized and some addition facts and some subtraction facts, and since we have our multiplication tables, 0 through 12, I should say, memorized, then we should have our division pretty well down with those numbers. Now, square roots as well, there's going to be some stuff that we would like you to memorize, especially while we're not able to use a calculator. Square roots, which I think we saw a little bit of this in Module 1, just in case we've forgotten. This is the symbol for square root. Now, square root is like finding the side length of a square if you have the area to start with. So if I said you started with an area of 100, can you tell me what the side length of that square is? Now, since we know our multiplication tables, that would be 10, of course. But here's the thing is if it says find the square root of a negative. Now, this means the negative is on the inside of this square root. That's not okay because there's no number that I can multiply by itself to get a negative. Negative 5 times negative 5 would be positive 25. Negative 3 times negative 3 would be positive 9. You can't multiply two negatives together to get a negative. So the area of a square should never be negative. And that's what you get if you say the square root of a negative. Let's just look at what one of these may look like, the square root of negative 9. You can't do that because you can't have a negative area. Area is always calculated in terms of positives. Now, that's if the negative is on the inside. That's not okay. If the negative is on the outside, so it may look something like this, where you got the negative square root of 9, that's okay. If the negative is on the outside of that square root symbol, that's okay. If it's on the inside, like we see here, not okay, which means it's not real. So on the assignment, it's going to give you this type of stuff, and it's just going to say, tell me if this is real or not real, rational or irrational. Now, to determine rationality, like we've seen already with comparing rational and irrational numbers, if a number is taken a square root of, but it's not a perfect square, that's these purple numbers in both sets, then it is considered a irrational number. Okay, so yeah, taking the square root of anything else other than these will give you what is an irrational number. And if you were to put these into your calculator, you'd find that they're very ugly. So you can see here that square roots have to do with powers of 2 as well. These are what we would call inverse functions, exponents and roots. So 1 to the power of 2 is 1, so the square root of the purple one is 1. 2 to the power of 2 is 4, so the square root of the purple 4 is the base 2 in red. Or moving down here, like the 8 to the power of 2 is 64. So if you wanted the square root of 64, you'd get just a regular 8. Again, that's just the side length of the square with this area that's 64. And all the way down to 12. Okay, so these numbers are important. These numbers you should have memorized because they're part of your multiplication tables. If you don't have them memorized, that's okay. If you were to go back to the multiplication table, and I don't have it, of course. I'll see if I can find it for later. But it would have been the diagonal on the multiplication table because, right, like 1 and 1 is 1. Or 2 and 2 is 4. And then you'd have this diagonal, and you'd get all these purple numbers right here. Now, we haven't seen that multiplication table in a long time. Again, I'll see if I can find it. But for now, hopefully that kind of helps us remember. Okay, so again, this one is not asking us to evaluate anything. It's just saying, tell us if we have a rational, irrational, or a non-real number. So if we were to look back at that list, okay, well, I can see that it has the square root of 49 is a 7, right? Now again, it's not asking us to evaluate, but since that comes out as just a regular 7, 7 is what we would consider rational. Boom, rational. I got the comma, I couldn't not copy it. Okay, how about the square root of 41? Well, 41, it's not negative on the inside, that's okay, but 41 is not on this list, so if it's not on the list, it is automatically irrational, automatic. Okay. Now if we go down to this is negative 13, square root of negative 13. The negative is on the inside, so 13 not on the list, so it is, you could say it's irrational, but this one we would just classify, since the negative is on the inside, this one is just simply not real. This next one, the negative square root of 16, the negative is on the outside, that's okay. And in addition to that, the 16 is on the list. We can find that right here. So this one simply is rational. Now this last one here, this is the square root of a fraction. If you have a square root of a fraction, that's okay. You just got to look at the numerator and denominator separately, which we'll talk about. But I would look at these numbers. I'd say 36. Is that on the list? It is. So that's going to check off. The 64, is that on the list? Yeah, we've already seen that one right there. Since both are on the list, but only since both are on the list, this would be considered rational. Since both the numerator and denominator are on the list, this is rational. Boom. Now again, I know we're not using calculators. You can't use calculators on the quiz, but just while you're doing these on the assignment, you could type these in and just see what comes out. Like if you type in the square root of 41, right? It says the square root of 41, which means it's irrational. Or if you wanted the decimal, you push the double arrow button above enter, and it gives you a really ugly decimal, which tells you, it's another way to tell you that it is irrational as well. Here's the other thing. If you type in the square root of negative 13 into your calculator, it says domain error. That's another way to say that it's not real. Oh, but I haven't shown you how to type that into the calculator. All right, on the calculators that we're using, the button progression for this, let's say you wanted the square root of 41, okay? So to get the access to the square root symbol, you've got to push the second button here. And then after that, you will push this button right here. It's one button to the left of 7. It's x squared. But you'll notice just above the x squared is a square root symbol. That's so that you know, that's why we type the green button in, and then this x squared button to access the square root symbol. And then you just type in 41, enter. Now again, when you do that on the calculator, it'll say square root of 41. And then over here, it'll say square root of 41 when you push enter. If you push the double arrow button just above the enter button, then it will give you that pretty ugly decimal, which my calculator showed. It'll say the square root of 41. It might show the double arrow button here, but mine shows 6.4031242237. Okay, now it wants some evaluation, so let's do that. Okay, now I'm not going to show the list again, but right here it would say the square root of 81. What multiplied by itself is 81? Question mark. Now, if you take some time to think about that, you'd know that that is, yeah, very good, it's 9. So the square root of 81 is 9. The square root of 89 is 1 because what multiplied by itself is 81. Now, it's kind of the same question right here, and I'll type that one out too. So what multiplied by itself is, again, it's not 81 this time, it's negative 81. And this is where we run into problems because some students would say negative 9. Well, negative 9 times itself, negative 9 times negative 9 is positive 81. So as it turns out, this is one of those where we would just say this one correct. Not real. Boom. Now this last one right here is the negative square root of 81, which means that the negative is just going to stay as part of the answer. But again, that's because it's on the outside of that square root, and we already know that the square root of 81 is 9, so we'll just say that this one is negative 9, and that's it. So we have 9, not real, and negative 9. It's important to know the difference between those because usually there's a question like that has all three of these on either an exam or quiz. Okay, so like we saw before on that one where it was like, is it rational, irrational, or not real? If we see the square root of a fraction, you just take the square root of the numerator and denominator separately. So it'll start out like this, but just separate the two into their own separate individual square roots and then evaluate from there, which again is why this is, I mean, you can always refer back to the list that we have. Well, this right here. If you can have this memorized, which again, it really is just the multiplication tables, right? Like what times itself is 36? Hopefully we know that that would be 6. Or what times itself is 100? Hopefully we know that's 10. So if you need the list, feel free to look at it. But again, you won't be able to do that on a test or a quiz. But this is going to help us with this by separating these. Because they're not usually going to, when they have these in fractional form, they're not usually going to give us anything that's going to come out as irrational yet. Like this one. Again, if it's not real, yeah, there we go. It'll say write not real. So on the assignment, when it does, you just write not real. This one, the negative's on the outside, so this one is going to be real, which means we're expecting this one to be rational, okay? So it is going to be a negative. What I'm going to do here is I'm going to show it like this. So I've got my two parts of the fraction. I got my numerator and denominator. But I'm going to separate them. So I'm going to take the square root of 25 and the square root of 100. Now again, if you don't have that list memorized, what you want to do is just look at them separately. So you just ask yourself, well, what times itself, let's start with the numerator. What times itself is 25? Well, that would be 5. And then you can ask yourself, what times itself is 100? Well, that would be 10. Now, even this, I've got negative 5/10. Always check your answer to see if it can be simplified because 5 and 10 are both divisible by 5. So I will simplify these into a new fraction, although it has the same value, into negative 1/2, and that's good enough. And by the way, just so we understand, the 25 over 100, that could have been simplified back there. Either way, you should get this answer of negative 1/2. Okay, so this one, I say this is kind of tricky because it's like, all right, we got a square root of a decimal, which maybe we weren't expecting. At least I wasn't. Okay, so what I'm going to do is I'm going to take that negative 81 hundredths and I'm going to make it a fraction, 81 hundredths. Like this. Now I got the negative out front, and that's okay. It just means that my fraction is going to be a negative. So I've got my negative fraction, and this is where we split them up, right? We've got the 81 and the 100, but we're going to take the square root of both of them. Okay? So this will give us a fraction. It'll be equivalent fraction, just shown differently. So it's starting with the top. Again, I don't care about the negative. Square root of 81, what times itself is 81? We've already seen that is 9. And then down here, the square root of 100, what times itself is 100? And yeah, we've seen that as well as 10. So now again, we just check this final fraction, negative 9/10. Can the 9 and 10 be simplified? They cannot. That's done. Okay, if we're estimating, what we're going to do is it's going to say, well, estimate this square root. Okay, so what you want to do is find ones that are close to it, the closest ones to it that you can possibly find. The one above and one below. You just kind of have to estimate from there. So it says, take the square root of a non-perfect square. We'll place the overall value between the nearest perfect squares. So we're going to need this list when we look at these. So like this example says, estimate to the nearest whole value. Okay, so we've got the list there. It's the square root of 47 which appears to be between 47 would be between 36 and 49, this perfect squares here, which means that it's between either 6 or 7. The question is 47 closer to 49 or is it closer to 36? Well, 47, of course, it's not really close to the middle of those. It's clearly closer to the square root of 49. So this one, estimating to the nearest whole number, we'll put the estimation symbol there. It's about 7. Or at least, at the very least, it's closer to 7 than 6 when it asks for specifically a whole value. Now, in the future, they may ask us to round. Here's what I would do is I would type this into the calculator. So I would type in the square root. It says, let's see if I can put this in. The square root, it's 47, and I push enter. Well, I got to push the double arrow button. And on my calculator, it gives me this decimal, 6.8556546. This is what my calculator gave me. It's saying round to the nearest whole value, which is the 6. So I look one place value to the right, which is the 8. So I'd have to add 1 to the 6, and it's closer to 7. Boom. Now that's using a calculator, which I'm okay if you do because this is just stuff that's going to be on the assignment. But I believe there's going to be questions like this on either the exam or the quiz. Now this one says round to the nearest tenth. Okay, now if I was looking at 95, I see it's closer to 100 there, which means it's going to be like 9 point something. Now in my head, if I had to estimate this, I'd probably say 95 is 5 less than 100. I'd probably say 9.7. Now that's just a kind of a math nerd's guess. I don't really want you guys guessing. This is where we're definitely going to use a calculator on this, okay? So round to the nearest tenth, estimate to the nearest tenth. So again, I'm just going to type this in, square root of 95, push my double arrow button, and my calculator gives me this number. So it says 9.7467. 94345. This is what it gives me. And again, this is irrational, which means this decimal will go on forever and ever, but never repeat or terminate. So it says, so yeah, on this one, we are rounding to the nearest tenth. That's where the first 7 is there. We look one place value to the right is a 4, so the 7 is just going to stay 7. And we end up with rounded to the nearest tenth, 9.7. I think that's what I said. Okay, without using a calculator, determine which 2 consecutive whole numbers the square root lies between. Okay, so again, 26, I'm looking at the 26, the square root of 26 if you would like, but I focus specifically on the inside, which that's called the radical, maybe the radicand, whatever. Okay, 26 is between 25 and 36. So I look here, and I pulled this off the list, right? So 25 is the closest perfect square. This one's closer to 5. That's not what it's asking. It's saying, which 2 numbers is this between? Well, I just found it in the list. It's between 5 and 6. Done. We say, well, that's pretty good with, we didn't use a calculator, and then we had a list in front of us, and that makes it nice and easy. Here's the thing is, if you were to use a calculator, so I would just type this in, right? And I know we're not supposed to use a calculator, but I'm using one. Just to show you that it is between 5 and 6. So the calculator, when I put this in, it says it's 5.099019514. Okay, so I get a 5 here, which means it's automatically between 5 and 6 because it's a little bit more than 5 with the decimal, which means it's less than 6. More than 5, less than 6. More than 5, less than 6. More than 5, less than 6. Between 5 and 6. Okay, now we are using a calculator for these ones. So it's the square root of 38. Now again, if I were to say which 2 numbers are between, well, 38 is between 36 and 49, so it's between 6 and 7. Again, I don't really care because I can use a calculator. So square root 38, I put my decimal in there. So it says it is 6.164414003. And it says it wants 2 place values. So from the decimal, we've got 1, 2 place values. The 6 to the right is a 4, which means the 6 will stay a 6. So rounded to 2 decimal places. The square root of 38 is approximately 6 and 61/100. And writing is hard.
Well, I was like,
Let's see if I can fix it on this last one. So it's 6 and 16/100. Better. Let's see if I can do this one better. So again, I'm just going to put in the calculator square root of 232. I put a decimal at the end of mine, so it'll give me the decimal directly. And it says it's 15. Let's see if I can do this right. 2, 3, 1, 5, 4, 6, 2, 1. It's the same number of decimal places, right? So we got the 2 and the 3. To the right is a 1, so the 3 stays a 3. We end up with 15 and 23/100. Here's my decimal.
so
I think I wrote that correct.
So that's it.
Yeah, so that's it. There's our objectives. I know the difference between rational, irrational, and non-real numbers. I can change decimal to a fraction, but a fraction to a decimal as well. And then I can order decimals from least to greatest, and I can evaluate square roots. We did it.